Hello, you asked how to solve these two equations. So we have 3 to the power of 5x equals 27 to the power of 2x plus 1. We also have 5 to the 5x minus 6 equals 50. Now we need to solve both of these equations. One of the things to remember, we may not need it for both of these, but remember that base b to the x power is equal to some quantity is the same thing as saying log of that same base, b, of this quantity equals the exponent. And we can switch back and forth on these. Okay. Now, when I look at this problem, I notice something. I notice that 27, so 27 is a power of 3. 27 is 3 times 9, and 9 is 3 times 3. So 27 is 3 to the third power. So I'm going to rewrite 3 to the 5x. I'm not doing anything to that. But I'm going to replace the 27 with 3 to the third power. That's 2x plus 1 out here. So all I did is I just replaced the 27 with a numerically equivalent expression. They are the same. Okay, again, I'm not doing anything to this side. But on this side, the rules for exponents are when you are taking something with an exponent to a power is that you multiply them. So we have 3 times the quantity 2x plus 1. So we put that in parentheses, and we're going to go from here. Now, we notice that we have the same base now. They are both base 3. So that means that the exponents have to be equal to each other. So we know that 5x has to equal 3 times 2x plus 1. This is now a relatively simple algebraic equation. So again, not doing anything to this side. And then multiply with the distributive property. Then I get 6x plus 3. Subtract 6x from both sides. Normally, I do try to avoid a negative coefficient for my variable if I can. In this case, it would actually make it more work, so I did not. But I don't leave my answer like this. I multiply both sides by -1 or divide by -1. It's the same thing. And it just swaps the signs for both terms. Okay. Now, on the next one, I am not going to give you the numerical answer. I don't have a calculator on me, and you're going to need one. I'm going to show you how to get there. So the first step, it's not in this form right now, but it's not that far from it. I add 6 to both sides. I get 5 to the 5x equals 56. Now, if 56 were a power of 5, so like 27 is a power of 3, we could set this equal to that and be done and be pretty similar to this one. But it's not. So we are going to transfer from this form to this form. So our log, our base is 5. The a is 56, and that equals 5x. Now, some calculators, you can just plug this in. Most you cannot. We're going to use the change of base formula. So we are going to have, you can either use the common log or the natural log, because they're both commonly found on calculators. I'm going to use the natural log. So the natural log of this quantity, 56, divided by the natural log of 5 is equivalent to this statement. That's the change of base formula. If you have no idea what I'm talking about, go back and look in your textbook. It will be in there on this section. Okay? Change of base formula. This is a number. You're going to plug it into your calculator, you get a number. You take that number and you divide it by 5. Okay? And that is how you find your value of x. All right, I hope I was helpful.